Hey algebra friends, here we are. We're going to talk about slope in this lesson, and we're going to define a little bit more solidly a concept that we've talked about a lot. So we've discussed graphing lines, and when we talked about graphing linear equations or lines on an xy axis as we have here, we've talked about a quality that they have, and the quality is their slope. And so slope is the quality of a line when actually slope and rate of change are really tied together. Slope is the quality of the line that refers to how high up you go and how far over you go from point to point. So if I had a numerical value for this distance and a numerical value for this distance, and I made a ratio out of it, sometimes we refer to it as rise over the run being the change in x, and the rise being the change in y, right? If I had a ratio here, that numerical value would be the slope. The slope is oftentimes referred to as the rate of change because it tells me how much y changes over a certain amount of change for x. So these two words are really related. So let me just get down to business a little bit. So slope, we usually use the variable m. That'll come up later in the chapter. We talk about it as rise over run, as I have written up here. We also call it the change in y over change in x. Sometimes the triangle is used, triangle being the Greek letter delta. And delta in science often means change. So delta y over delta x. And sometimes you're going to also see this. Y sub 2 minus y sub 1 over x sub 2 minus x sub 1, where I'll tell you what this has to do with. This basically has to do with if I tell you that the 2 points here, let me make this all obvious and stuff. Here we go. If I were to refer to this point as, let's say, x sub 1, y sub 1, right? And this point, since it's another x sub y, I'm going to call it x sub 2, y sub 2. The sub values let me know I'm talking about different pairs of x and y's. So if I were to have the numerical value for these ordered pairs, I would be able to take the difference in the y values divided by the difference in the x values, and that would also give me my slope. So all of these definitions that we see here, all of these ways of thinking about slope, is basically what we're going to cover in this chapter. All right. In addition to that, keep in mind that slope and rate of change are often synonymous. Generally, when we talk about rate of change, we're going to talk about whatever the unit is when we're dealing with a problem. It'll make more sense when we do some examples. So here in example 1, we're going to look at a situation where our slope value is going to be positive. And basically what we're going to do is use that definition we talked about before. Remember, slope, the variable we use is m, and one definition is the change in y over the change in x, written as y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So what I'll do is I can literally, if it makes me feel comfortable, just name the points. I'm going to name this the point 1, so it's x sub 1, y sub 1, and this will be point 2, x sub 2, y sub 2. And just like we did when we first started algebra, we're just going to do some substitution. So we get 4 minus 2, y sub 2 minus y sub 1, over 3 minus a minus 1. 4 minus 2 is 2, 3 minus a minus 1 is 4. We can reduce that. Our slope is 1/2. So every time the y value goes up 1, the x value will go out in a positive direction too. This is a positive slope. We'll talk about the orientation of slope, whether it's positive, negative, undefined, or 0, in a moment. Again, we're going to talk about slope using the definition of slope, recognizing that the variable we use is m. I'm just repeating this so you remember it, don't worry. So recognizing that the variable that we use is m, and then we've got the change in y over change in x, written as y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Again, if I choose to, I can label them to keep my brain, focused on what's what, but there'll come a time when you probably won't do that. Anyway, so we're going to subtract 1 minus a negative 2, 1 minus a minus 2 over negative 4 minus a minus 1. Negative 4 minus a minus 1. When I do that, I'm going to get 1 minus a minus 1. We know that's going to do 1 plus 2, right? I'm sorry, 1 minus a minus 2. That becomes 1 plus 2, which is 3. Negative 4 minus a minus 1 becomes negative 4 plus 1, which is negative 3. I reduce that and I get negative 1. I could look at it as negative 1 over 1 or just as negative 1. That's my slope. I feel like somebody is saying right now, but what if I called this one x sub 2, y sub 2, and this one x sub 1, y sub 1? And I would be saying, thank you for asking that question. Let's see if we get a different slope with the red slope, right? So we're going to continue with our formula, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And now we're going to do it the other way. So y sub 2 is now negative 2. Negative 2 minus 1, that's what I got at the top. And at the bottom, I have negative 1 minus a negative 4. When I simplify this, negative 2 minus 1 is negative 3, and negative 1 minus a minus 4, I'm going to change that to addition, is going to be a positive 3. And we notice we still have a negative 1. Does it matter that the negative is on the top or the bottom? Absolutely not. In this case, what I wanted you to see with both situations is it doesn't matter which one you have as your first xy and your second your first x sub 1 y sub 1 versus your x sub 2 y sub 2. Doesn't matter. Once you make sure that if this value is a sub 2, then this one has to be a sub 2, and if this one's a sub 1, this one has to be a sub 1, right? And we keep our x and y straight. Hopefully that's clear. Sometimes we can have a slope that is 0. We'll start off like we did last time, using the same formula that we've done before, right? X sub 1, y sub 1, x sub 2, y sub 2. When I do that, I know that slope is equal to the change in y over the change in x. And so we have 2 minus 2 over negative 1 minus, that's a comma, sorry about that, negative 1 minus 1. And so 2 minus 2 is 0 at the top in our numerator, 0 in the numerator, and negative 1 minus 1 is a negative 2. So in essence, 0 divided by anything is 0, we get 0. So a 0 slope is going to happen. What was the situation that caused this zero slope to occur? Hopefully you see that the y's are the same. And if the y's are the same, you're going to get a 0 slope, right? Because there's no change in y. So if the y term of your 2 points are the same, you're going to get a 0 slope. We're going to look at graphs of this in a moment. So the other type of slope that we need to concern ourselves with is an undefined slope. Notice that the x values are the same, and that should give you some indication as to what's going to happen. But let's pretend we don't see anything weird. We're just walking down the street. We're naming our points, x sub 1, y sub 1, x sub 2, y sub 2. We're going to calculate our slope by doing what we know, the difference between the y sub 1 and y sub 2, y sub 1, and the difference between x sub 2, x sub 1. And we're going to do the thing we're supposed to do. 3 minus a minus 2 over 1 minus 1. 3 minus a minus 2 is really going to be 3 plus 2, which is 5. 1 minus 1 is 0. And here, you know, this is like bad problems, bad problems. Nobody likes this. You didn't think I'd sing in this video, did you? But I did. This is a problem. Mathematicians are flipping over in their grave when people write things that are divided by 0. It is bad. It is wrong. It is horrible. So we know that this is undefined. Right? We cannot divide by 0. It is undefined. We have an undefined slope. Let's go back and talk about what each of these situations look like. Going back to our first example, I plotted the 2 points, negative 1, 2 and positive 3, 4. I'm drawing a line to represent the line that these 2 points must lie on. Notice when we have a positive slope, our graph will go up to the right. Here, looking back at example 2, we plotted the points, negative 1, negative 2, and negative 4, 1. And we see that this is what happens when we have a negative slope. Our graph goes up to the left. So this is our negative slope situation. Graphing number 3, example number 3, I graph those 2 points and a horizontal line emerges, and so this is when our slope is 0. We get a horizontal line. And finally, when we're graphing an undefined slope, notice I put the 2 points here, 1, -2, and 1, +3, we get a vertical line. Vertical line is an undefined slope. There we go. All right, so these are the 4 ideas that you need to keep in mind as we're working with slope. I know we've discussed this in class, but I find this to be very helpful when I think about lines. I like to just quickly, okay, positive slope, it looks like this, negative slope looks like this, 0 slope, and undefined slope is a vertical line. Cool beans? Now a little bit of interesting problem solving. So we need to find the value of R, and I've seen these on standardized tests, so I think it's worth taking time to look at this example. You're given a point, 1.10, -3, and another point, R 6. You got to figure out what this R value is, and you're given the slope of the line. You feel in your heart that you have enough information, but you're not quite sure how to put it together. Don't fret. Remember, the slope is equal to the change in Y over the change in X. You already know how to solve proportions, and we're going to kind of make a proportional problem. You might say, I hated proportions, but that's okay. You'll be fine. So when I do the change in Y over change in X, I'm going to end up, let's say I call this my X sub 1, Y sub 1, X sub 2, and Y sub 2. So I'm going to have -3 minus 6 over 10 minus R. -3 minus 6, 10 minus R. And that should equal the slope that is -3 over 2. And now I'm going to do as much simplification as I possibly can because I told you this is a proportion. So when I look at this, I get like -9 over 10 minus R is equal to, and I know this is a -3 over 2, but it might make you feel better to place the negative somewhere. What I mean is -3 divided by a +2 is still -3/2, and 3 divided by a -2 is still -3/2. So in a way, you have a choice to place the negative where you want. I'm going to put the negative down here. -3/2 is the same as -3 over a +3 over -2. All right. So now what I'm going to do is solve it like I know how to solve proportions. Some of you might have already kind of figured out how to do it. 3 times a -3 is -9. Therefore, -2 times a -3 equals that, and doing some stuff. We're going to solve it like proportions just to give a little practice. So proportions told us that the product of the means is equal to the product of the extremes when setting 2 ratios equal to one another. Therefore, I can multiply these guys together. So I get -9 times -2 is equal to 10 minus R. I need to put that in parentheses because that's a whole like thing by itself, times 3. You know, when we have things in parentheses and a number being multiplied on the outside, that screams distributive properties. So distribute, we get 30 minus 3R is equal to 18, +18. Now we're going to solve this like we solve all equations. We're going to isolate the R term by throwing the 30 on the other side. We can think of it passing through some vortex of the equal line. Vroom, it becomes negative, or we can add -30 to both sides. When I do that, I get a -12 over here, which is equal to -3R. I'm going to divide both sides by -3, as you know, and I get that R is equal to 4. So, find the value of R so that the line, blah, 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 that passes through these 2 points has this slope. We did it. We can plug it back in if we wanted to and check to make sure that the slope is the same, which is helpful, definitely. If you'd like to do that, do it. All right, so go ahead. Let's take a look at example 6. Find a rate of change. So dining out, the graph shows the amount spent on food and drink in the U.S. restaurants in recent years, maybe not so recent. Find the rates of change for 1980 to 1990 and find the rates of change for 1990 to the year 2000. And so we'll do that. The first thing we'll do is represent the data as points. 1980 is with $120, 1990 $236, 2000 $376. Now we'll find the slope of these 2 points, of these 4 points rather. So after finding the slopes of each, right, change in Y over change in X and reducing it, we see that in this time period, we see that the change has been $11.06 per year, and this is $14 per year.